Okay, I think it's recording. Cool, cool.
Thank you. All right, so I'm going to talk about pipes and composability.
Oh, sorry, I'll try and try and get this knowing that it's coming up. Oh, okay, it's here. Get the video on the slides. Okay, go for it. Cool.
So can I click?
So I think it's not being recorded. You should click on the record button.
Oh, okay.
It says recording.
No, it's recording.
Oh, okay.
So,
Different screen, yeah. What do you want to get? Do you want to get rid of the camera?
Yeah.
There's a minus button there,
I
right?
can do that, but it just makes it very small.
Oh.
There is another one.
I mean, it,
Hard to do.
all right, right, this one.
Sorry.
All right. So I'm Jonathan Carroll. That's cut off, but if you want to go to my website, you can go to that one. I mainly write R, which is probably not that many people here use, but I love it. I'm also learning a bit of Python, definitely learning Julia, going through Rust at the moment. But I've originally started my PhD in Fortran, which really doesn't lend itself to the functional aspect of subroutines and a lot of procedural stuff. But I've dabbled in a whole bunch of languages. So I'm going to do my best to offend every single person in this room with a really bad take on how to do pipes in each of the languages and how they compare. So do hit me up on the Bird site or I'm on Mastodon or GitHub or the web. So I started using pipes in Linux, which I think is probably one of the first places that they were around. So the general idea of a pipe that, let's say you do cat or file, which just basically prints the file to the screen and it has this number of lines. And what you can do is you can pipe the output of that to another function. There's a function called head, takes an argument and number of lines, 3 lines. So we take the output from catting a file, pipe it to another function that's going to take that as an input. And the result of that is we've taken some data, passed it through another command, and we produce a different output. And you can keep doing this into different pipelines where you take some data, pass it through something, pass it through something else. It does a word count the number of characters that are in the previous thing, and there's 71 characters that are in that. This is where I started using pipes. I then stopped using them for a whole long time and then have come back to them in the functional sense. But in general, Unix commands, they are functions. So this is the function add. It takes 2 arguments which are not provided by name. It takes a first positional argument, a second positional argument, use the calculator to add them together and then prints the result. And if you pass in 2 arguments, a 3 and a 5, you get an 8. But that's a positional argument. And we were just talking about taking some data and passing it in. If we didn't pass it in as an argument, we passed it through a pipe. So what this version of it does is it looks for an argument, any argument, and if it finds one, it uses it. If it doesn't, it takes a default, which in this case is standard input. So now this add 2 function, if I pass in 5, which is given an argument, it uses that, adds 2 to it, and I get 7. But if I don't give it an input, so it just waits, then I type a 7 and then close that, that takes the standard input, passes that in as the first argument, and adds 2 to 7, and I get 9. Finally, if I wanted to take 7 and then pipe it, which means given the input from the left-hand side, pass it to the thing on the right-hand side, now I've got something that's piping into another function. So we've redirected the standard input into the argument of a function. And this is where I'm going with the whole notion of piping in general. So on the left, we're going to take some input, pass it into a function with a pipe, and that's going to produce a function acting on that input. But what if we wanted to use the second argument? So I had just a $2 previously, but you can't pass in standard input into that for a positional argument. So in this case, we do some really funky stuff and we say that given an input into this function that takes an A and a B, it's going to put it into the first argument. Now, if you wanted to use the second argument, now we have to get into the idea of having something else that says where to put that argument. We'll come back to that. And in general, the idea of composition is very similar to this, that if we have some composition of G and F, then H acting on some input is G of F of X. But this is very similar to piping, that if we took X, piped it into F, and then piped that into G, we'd end up with G of F of X. So the idea of composition and piping are very, very similar and tied together. This is a post I love called More Shell, Less Egg, that right back when the very first good languages were coming out, Douglas McElroy, the inventor of the Unix pipe, was talking to Donald Knuth, who you know from many things. But Donald was working on Web, which is a literate language where you can sort of interplay the documentation and the code all in one place. And the challenge to Donald Knuth was, can you write this program in Web that does this, reads a file of text, determines the n most frequently used words, prints out a sorted list of the words along different. And Donald Knuth did this. He did it using Web, which is Pascal. This ended up being a 10-page, whatever meaning of page that is, program that has all the documentation weaved in with it. So like, we'll excuse the size of it. And it was a very clever, like purpose build, probably had a hash table of exactly what words had what counts and all of those things. But the response to it was a pipeline. And people think of this as just a one-liner, really, if you put it all on one line. That you transpose some things, sort them, take unique, sort them, and then run it through a stream editor. But this idea of Unix functions that are small things that do one thing well, and you compose them together, it makes a lot of sense for the functional programming world. I've got this one thing that it does something really well, but I need it to connect up to all of my other things. And this idea of a pipe, I think, is where that really comes together. So I'll talk a bit about R. R has a data frame loaded into it, so we have columns of data. You can run head just like you can in Unix. You can run head and get like the first n number of rows. There's a function I've just chosen at random, the col sums, which takes the sum of each of those columns. So now we've composed together col sums and head, and we can get an answer. Each of those functions takes some arguments, so we can pass in instead of the default of 6 rows, we want to take the first 8 rows. And col sums has an argument that do we want to remove the NA values? We'll say yes. And now this starts getting a little bit awkward because this n equals 8 goes with head, and that's fine, it's sort of nearby. But this NARM is true, goes all the way over here with col sums. We've really separated out where our arguments are from the function calls that we've got. And this gets really messy. The example I like to use for this is some little bunny foo-foo, we're popping through the forest, scooping up field mice, popping on the head. So let's create a little foo-foo, which is a little bunny object. And we can sort of play out this idea of functions with function calls that do all these things. So if we try to read this, we've got little bunny foo-foo, we're going to hop through the forest, scooping up the field mice and bopping them on the head. Oh, no. And you can see you've sort of got to read this from the inside out, and that's not ideal. The arguments have become quite separate from where they want to be. On the head goes with bop, which is all the way up here. And this is not nice to read. You can work with this, but if you need to add a few more arguments, or say add a lot of arguments, this gets pretty ugly. So how do you deal with this? One option, just create some intermediate variables. So let's create a foo-foo1, which is the result of doing hop on foo-foo through the forest. And then we'll pass that into scoop, and we'll pass the result of that into bop. And this is certainly one option you can do, but again, now we've created variables that we don't want, we don't need. We can just get rid of them. So we can just make them all the same variable. R's fine with overriding variables. So we can just update foo-foo to say, okay, now it's been hopped through the forest and now it's scooped up the field mice. But again, we're just overwriting the same object over and over again. It's not necessarily ideal. Why do we need the variable at all? We could just use a dot. Dot is a valid variable name in R. So let's just call it dot and then pass dot through all of these things. And essentially someone's taken this idea and made an index operator for it. I love the package for this is the Magritte package for Magritte, who had the painting of the pipe. And this is a pipe. This is not a pipe. So in general, for R, we take the composition of function and we can replace that with this idea of taking a dot, put the dot in here, put the dot in here, and we have an infix operator which does exactly this. So redefine X as dot, passes it into F, passes the result into G, passes it into H. So if we do that with the data that we have in R, start off with this object, pipe it to head, pipe it to col sums. We get the result we got before, but now it's a bit clearer, a bit easier to read. We go back to our difficult to read example. This is now the starting object, goes through the pipe, pops through the forest, scoots up the field mice, pops them on the head. This becomes a lot more readable. You can see where the arguments go, you can see that they go with the functions that they've come from. And with this piping step, we've taken small, simple things that do one thing well, we've managed to join them up together in the exact same way that you would for a Unix pipe. One of the other advantages is that in R, functions are first-class citizens. So you can do all of the same stuff like you would in Lisp of taking a function, treating it like data. So we can take the function head, get the class, that's a class function. We can count the number of characters in the word function, and we can just pass these things through. You can pass anything through one of these R pipes. As I said before, one of the difficult things is that if we've got something that takes multiple arguments, by default, it's going to put that result from the left-hand side into the first argument of the right-hand side. And what the Magritte package does is that it uses a placeholder. In this case, it's the dot. But if we had a function that takes 3 parameters, and we're going to produce the parameter itself, the square of the second one, and the cube of the third, we can take this 1 to 3, so 1, 2, 3, pass it, pipe it into the powers function, there, and there, and there. And we get 3 results here of doing the piping into all 3 of the arguments. So we can actually reuse the argument as many times as we want. So the idea of having a placeholder that we can maybe reuse allows us to put things into other arguments. But this has been a big focus in R, making sure that the data is the first argument of input to many, many functions. So that if you wanted to pipe them together, you can. If you don't have the data as the first argument, and the first argument is a switch of some sort, then that's what's going to by default get piped into. R recently gained a native pipe, which has a different symbol for it, but is supported in the base package. And this is purely syntactic sugar, for better or worse. What's the quote that syntactic sugar leads to count through a semicolon? There's a lot of placeholders here about like, what you can do with what placeholders. But yeah, native pipe in R. So as we were saying before, compose, very, very similar to pipe, but you can imagine building up compose in R, which is just a function takes F and G and literally just composes them together. And R has some support for actually doing that through packages. So now I'm going to start offending people. I'm going to go through other languages that I'm not as familiar with. But Python method chaining is much, much more common. But I think if you squint, you can start to see if you take some data and start just dotting things together, if this was a pipe symbol, this would look pretty similar to what we had before. So the idea of method chaining and piping, very, very similar, obviously with very different caveats associated with them. Also in NumPy, so you can do the same thing, put it all in one line. And Pandas recently gained dataframe.py, which I think is probably the worst implementation of any of these. Now you literally have to write the word pipe. Julia takes a similar thing to what base R now has, but inspired by the other languages. So you can just take some data, pipe it through into a number of rows and get 32. They also have an extra package which extends the functionality of that. So you add a macro, it's like a Python decorator, and you can do other things. I'm not 100% sure exactly what you can do with it, but you can. One of the really cool things I like about the pipe in Julia is that because the pipe is itself just a function, it can behave like a function. So in Julia, you can broadcast whatever you're doing. So the same as doing a map over several things, you can broadcast over piping. So this takes a lift of strings and pipes through each of these functions with broadcasting. So it does this to the first one, this to the second one, this to the third one, and that to the fourth one, which I think is really cool. So I'd be remiss if I didn't go back to some of the start of this. So F# has a forward pipe and a position. The forward pipe takes some value and a function that returns the value and returns just the value. So we can do this in F#. And again, this looks very similar to what we've had before. Carroll also looks very similar to the ones we've seen before, and I think it's one of the earlier ones. So with some definitions up here. We can take some values, we can pipe them and pipe them. In JavaScript, things look a little bit different. You can define a pipe operator, which takes some number of functions and acts it on some data, so backwards to what we were saying before. And you can do a compose, which is the opposite direction of that. But that does let you do something really cool. If you're defining this pipe function, you can throw a debugger in there, which is really, really handy. So when you've got this large amount of pipes that you're putting together, one of the hardest things is that if something breaks in the middle of that, what do you do? So with the debugger in there, you can step through each of those pipe calls and maybe step through them. JavaScript, there, definitely is a debate still going on. I don't know if it's been settled. Someone will have to tell me I'm out of date. The two options, it's the hack pipe, which takes a placeholder, or an F# pipe, which is like the F# one. Has that been settled? Right. But yeah, method chaining in JavaScript is much more common. Again, if you squint, you can imagine if this looked like a pipe, that would be exactly the same. In Ruby, we have the same thing we had before, where you can either do method chaining, or you can do it like this. But that has some interesting consequences that they have a dot operator that does various things before, and the precedence can matter. So you can do this with a pipe, but you need braces there if you're going to do it with a Closure uses a forward arrow, which is slightly different. But again, all the same ideas. The other one that I found was different, I guess, has to be don't. So in summary, pros and cons. Pros, the arguments stay with the function call. So you've got lots and lots of arguments that are in these pipelines. They all stay with the function that is calling them. You don't need to read these composed things from the inside out. You can read them linearly, which is nice, which I find more readable. And you can sometimes reuse the past input if you've got a placeholder. I think this encourages a more functional design. So it makes you think of, if I'm going to pass some data into this, can I make it a small function that I can just pass through a pipe, rather than just building some massive function that you know is going to pipe. And the last thing is it's clear intention. So you know that something's going into that. When you have like a bar and an angle bracket, I think it makes it very clear that you're piping that into. If you use certain fonts, you can get a nice ligature for that. And I think that makes it nice for what you're trying to do. The downsides, of course, this can be really hard to debug. So one of the big complaints about the infix version in the R reader package was that stack trace includes all of the function calls involved in actually building the pipe, rather than just some syntactic sugar of undoing it. With method chaining, you get autocomplete methods. So if you know what type you have, you press dot and tab, you'll be able to see what methods are available. When you're piping, that's probably not available. You do need to mentally shift the argument. So if you see something piped into something else, you sort of need to mentally put that argument into the first argument. And if there's a placeholder there, then that can sometimes be a bit harder to read. You do have to take care with operator precedence, depending on your language. And depending on the implementation, there can be performance issues. So if you have to write the pipe yourself, and it's not purely a syntactic operation on there, there can be some performance with that. That's all I had. It's a whirlwind tour. I think I've offended everyone. Thank you very much.
Any questions, anyone?
Did I get anything wrong? It's probably H wrong. I'll say about blatantly.
Cool. What about, I was talking about Go, because Go has these like channels that are like synchronization.
I've tried looking at Go and I did not get very far. Okay. It's like one of the few ones I started and I did not get very far.
Yeah, it's like very rigid as well.
I think I tried to add strings together, like concatenate them, and could not figure it out. And I felt as a new user, that should have been easy to figure out again. No, I'm not sure. I think there is something.
Nice. Good. All right, thanks very much for that. Okay, I'll go next. Wait, can someone check on the, you guys taking the door agents? Yeah.
Sorry, Jack.
Listen, yeah.
I just wanted to say thanks to Jono for the talk. I think there's one other con you can add to the last slide with the difference between composition and method chaining. Method chaining, all of the operations are provided by the object, where in composition and using functions, you can add you can add your own operators, and I think that's a very powerful thing that people often forget when they keep on adding methods to objects.
Yeah, that's a good one. Yeah. You definitely lose something by when doing the piping version. If you, create a whole new type or a whole new class or something like that, you know what you can do to it.
Nice point. I forgot to say, sorry, we have one or two people who are joining online as well today. That's who that was. Okay.